Okay, so this is just kind of an example of how you're going to find that potential energy by using the integral. Okay, so when you take that integral, oh, it's not a good color. Okay, so when you take that integral, right, that's how you're getting the mgh, okay, or the 1/2 kx squared. Okay, right, and then that gravity force is going to be negative, right, because we're saying it's, I guess, down as opposed to the displacement is up. Okay, and that when you're raising it, and then also remember from Hooke's law we have the negative kx. All right, so this doesn't show up too much, and most of the problems are just really simple and don't involve this, so I don't want you to get all confused with the negatives. Just think about what's happening. Okay, all right, so for example, right, work done by the spring force is most likely to be an integral because that force is not constant anyway, so that's usually kind of how it's going to show up. All right, so if you look here, you can see that they're telling you the force from the spring, okay, is kx squared. All right, and they're asking for the work done. So we know that the energy is the derivative of the force, okay? And so here, do you notice nothing's negative? Nothing, like, the negative isn't really going to matter in most cases, all right? So don't pay too much attention to it, but you're just going to see in this case that you have to integrate that, okay? So I'm going to integrate kx squared dx, all right? And then k is a constant. And then when I integrate this, I'm going to get that, right? Is that right? I think, because if I move that down, yeah. Okay, so the potential energy is going to be kx cubed over 3, which is going to be choice E. Okay, right? So don't freak out too much about the negative. Just kind of go with it. And then in the rare cases that it matters, you know, then we'll see. Okay? All right, I think that's